All right, this will be lab breakout game. In this lab, we are going to make a couple of changes to how we set up Visual Studio, and we're going to create a template project for Breakout that we'll be able to use going forwards. And then we'll be drawing some circles on the screen. So we're going to get started with just some familiarization. You'll want to use Git if you don't already have it. So if you don't have, say like Git Bash and all of that installed on your computer, you'll want to have that. And this is for the Windows install, but just open up a web browser and go to, just search for download Git. And that'll take you out to git-scm.com. They pretty much took over the open source Git client, and then just download whatever version is out there for Windows. And when you download it, just save it, and it'll go. I already had it downloaded, but it comes down very quick. And then when you get it here, just go ahead and run the installer and do the normal install. And then one thing we can do, we had in the previous video, I said to set up all of this stuff in C:, your root drive. It's okay if you did it under documents or anywhere else, but an OpenGL folder. And we brought down from GitHub the fgcugl files, and then GLEW and GLFW, we got the binary releases and brought them down. And so one thing I'm going to suggest is that for these that we already downloaded, and you would have downloaded them into your downloads folder in the previous video as zip files and then expanded them to here, I'm going to recommend, if you're following along and you're keeping your repos folder in your documents, so documents repos, we're going to make things simpler by copying these two directories into repos. They won't change throughout the semester as far as working with our project. And these are the expanded folders where we'll get in to use the include folders and the library folders. But then once you're in here and you've installed Git, the fgcugl libraries may change during the semester. So to be able to keep up with the most current ones, it's easiest if you use Git. So once you have Git installed, you can just open up Git Bash, which is a command line tool. And then from the command line, this tilde here means I'm in my home directory. And if I do a path working directory command, pwd, it'll tell me I'm in C:users p-allen. So I just want to get into documents and repos. So I do a change directory cd to documents. And then I can see I'm in home, which once again was C:users p-allen documents. And so now I want to change into repos. And I can see there, and if I do that path working directory command, I see I'm in C:users p-allen documents repos. And if I do a directory by doing a long listing LL, I'll see these folders are here now. Okay, so what I want to do is I want to bring down the most current fgcugl library, and I can always refresh it by doing this exact same thing. So if we look out on the web, we can find the GitHub by going to github.com/ and then it's p-allen fgcu is my GitHub library. And then the library we want is the fgcugl library. And that takes us right to the library. And then there's this code button here. And if we drop that down under HTTPS, here's the path through the web to get to download this library. So there's a little clipboard icon. I'm just going to click that to copy. And now I can come back to my bash shell script and I can say git clone and then paste that path. And then when I hit enter, it'll go out and download a copy of this into the path where I was, which is document repo. So there it is. And now it's got the two most recent versions of the file. And if later, basically every time I go to do a project, I can start by opening up Git Bash, navigating to my documents repos folder and typing the exact same command. You could even save this command somewhere, and that way I'll always refresh this. Also, if I change into, if I do, because notice in the directory now there's a git ignore file, and that's going to tell Git that this is a Git library directory. So I should be, let's see, if I change into the fgcugl directory now, I could do a git status, and it tells me I'm on branch main and that it's up to date. So I could actually go in here next time I'm going to do a project and do a git status from this path here, and it would tell me if main had changes out there and is newer, and I could then do a clone to refresh it. But safest thing is from the repos directory. You can always just do a git clone and it'll just reclone it. All right, and I'll be putting out to the class when we do have changes to that library. Okay, so that gets us now in repos. We have our fgcugl library and we have our glew, glfw, right? Along with any of our projects that we're doing. Okay, so let's get started with, I'm going to close this one. We're not going to use that OpenGL folder anymore, and we don't need the documents folder. All right, so now what we're going to do is we're going to get started with starting a new project, and we're going to save this project as a template when we get the basic part of it done, and then I'm going to demonstrate how we can create a new project from it very quickly with all of the stuff that we need already configured. So we're going to create a new project. All right, so we're going to create an empty project, and let's just call it Breakout. And then, and actually, this will be for our lab 2. So let's just go ahead and put 2 on it. And then we want it to be in that documents repos directory, and we want the solution and the project to be in the same path. All right, now we're going to need to go through the full setup this time, but we're going to save that, as I said, as a template so we don't have to do it again, and we're going to demonstrate that. All right, so let's start with some of the things that we're going to need. We need a source file to get started, because if I do properties right now on the project by right-clicking and going to properties, notice I have VC++ directories, but I don't have the CC++ choice here. So I need to give it a C++ file so it knows what kind of project we're doing. So I'm going to go to add. So I right-click source files, I go to add, new, and I left-click new item. And I'm going to pick a C++ file, and let's actually call this file Breakout. .cpp, and we can add that. Right. And then while we have it here, let's go ahead, this way when we see the file, we know for sure what we're in. Let's go ahead and add our template. And I'm going to do it with the endline comment marks this time. And I'm going to do file is going to be breakout.cpp, and then we need the who we are. So, and then our organization is our class, so we are COP 2001, and this is term 2021-01, and you're either in CRN 10410 or 10409, so just put yours. And then our description, this will be the main application file for the 2D breakout game. And then I like to, make this stand out. So I'm just going to go out and I'm watching over here in this bottom right corner what character I'm in. I normally will just kind of do these separators out to character 60. And the nice thing about it is you can use this elsewhere, just copy it, and you can use it elsewhere to separate blocks of your code. All right. We know, might as well finish off this template while we're here. We know we want to include IO stream. And the reason for including it is this is going to be our console library for debugging. All right. And then just our basic template, we need an int main. And then, okay, I am going to put down here that this is the end of main. And you'll see why. As these functions get to be very large, it's nice when they have to scroll across the screen that when you see a curly brace here, you know, an ending curly brace, you know what it belongs to. So we know it belongs to the beginning of main. And then the only thing we need right now is return 0, since main is returning. That's our basic template. So let's save that for right now. We're going to add to this, but we need to get the other libraries in. All right, so one of the things we're going to do, which is a little differently than what I've said before, is from our repos, let's go into the fgcugl library and highlight. I'm going to click the first one and then control click the CPP. So I've got the header in the CPP file, and then I'm going to left click and drag onto the project, not the solution, the project. And when I drop them, it'll link them into the project. Now they're not in my project folder. In other words, they're still in this repos folder. If I go back to Documents Repos and I go into Breakout 02, notice they're not in here. And that's okay, and that's going to help us with the template that we're going to create, in that the template will always link them to this folder, so they'll stay here. And if we update them, we'll always have the most up-to-date version in here. All right. So now we need to get the rest of the links to the includes and the libraries. So, oh, that was, sorry, it opened up the fgcugl CPP over here. I was wondering why we were seeing all this code. Let's just close that. And it's all in error right now because we don't have the rest of the libraries linked in. So I'm going to close that. We'll leave our Breakout CPP file open. And let's click on the project, and then you can right click and go to properties. Now let's set up the rest of our properties. Now we have the C++ configuration. And we can go into that, and in our general, in our additional include directories, this is where we want to go through now and edit, and then add, and then we can use the build button. And now we're in repos, our Breakout 02, just click on repos, and we can go right down in here, and let's just do glue first, and we need the include directory. And then you don't need to click on the GL, just the include is fine. It'll search that whole path. And then I'm going to add another one and click on the build, and that was GLEW. So go back to repos. Now we need GLFW and include. And then select that folder and click OK. All right. And we have one more to do. I meant to, let's click edit again. And it's not an include directory per se, but we need to include, as an include directory, the fgcugl folder, because it has that fgcugl file, and we need it to be able to see that. So click that as well, and then do select. All right, so we've got fgcugl in repos, glfw in repos, and glew in repos. So say OK. All right, and then we come down. That's it for the C++. I can collapse that one. And now in the linker, in general, we need to populate these additional library directories. So same thing, come in and edit, add, and then let's go, same order, we'll go to GLEW, and we'll go to the lib directory, and then we need to go into releases and Win32. We want to tell it which release to look we're looking for a file in. And then let's add, and once again in repos, glfw, and then whichever version I'm on, Visual Studio 2019, and that's good enough. Right, and we don't have to do anything for the fgcugl that doesn't have a .lib file. So say OK. Right. And then we go into the input, and now we need to add the actual library files. So first one is OpenGL32.lib, and that's in your systems directory. We just need to tell it we want to use it. Now the other ones, we need to browse for, to make sure we get the right one. So if we go back to our File Explorer, and we go into GLEW, and we go into lib and releases, Win32, we want GLEW32.lib. You can even like click into where you're going to rename it and copy that, and then hit like escape. Come back here, and right after the OpenGL32 lib semicolon, you can then paste that one into a semicolon. All right, and then same thing. We go back out to File Explorer and get back up to the repos directory and go into glfw. Now come down to that lib Visual C 2019. glfw3.lib is what we want. So I'm going to copy that name, come back here, and get between that semicolon and kernel, and then make sure you end it in a semicolon. So now I've got OpenGL32.lib, GLEW32.lib, and GLFW3.lib. All right, with semicolons between them. All right, and then I'm going to say OK. All right, now we were copying the GLEW DLL into our project folder, and for right now things are working without it, and it won't stay as part of the template, so I'm not going to worry about that right now. All right, but we've got all of our libraries. Let's finish off our basic OpenGL template, and then we'll save this. So one of the things we need to do to get started is we're going to need to include, and here we'll use the double quotes because we're picking from a project include. And you can see where it's pointing it to, our documents repos, fgcugl, fgcl.h, and that's what we want. All right? And then we're going to add some constant declaration variables here. And I'm going to do something like this. Actually, I'll just do it like this for now. We'll do, we're going to do a comment here and say global constants. All right, and then let's do, we need a constant int for integer, and we'll call this the window width. Remember, we do all capitals with underscores between words for constants. And let's just set that right now to 200. And then a constant int window height. And we'll start that out as 200. Right? And then let's do a constant standard namespace string window title. And we'll set that equal to breakout. All right. So now in our basic template, the very first thing we need to do for GL, for OpenGL, is to open a window. So we'll do from the fgcugl namespace, open window. And now here it wants a width, a height, the title, and optionally we can say resizable. And we're actually going to set that to false. We don't want the Breakout Games window to be resizable. So we'll do, we can just, you can actually, well, you can just start typing. It's kind of nice. You can start typing window, and as soon as you get close, you can use your arrow keys. So here's our window width. So I've highlighted it. I'm going to hit enter, comma, window height, and window title, and then I'm just going to say false for resizable. All right. Now we need a loop. That is going to be our main game loop that's going to keep our game running, and we want while not fgcugl window closing. And it doesn't take any parameters, but it still needs the parameter list set up. And then we need curly braces for the body of the loop, right? And within here, right now, all we need to do is paint the window. So fgcugl paint, window paint, and it doesn't take any parameters. And then we need to watch for events. fgcugl get events. And I don't know why on Windows right now, I don't know why the window closing event isn't getting caught, but I'll look into that some more. But this is what we need. This is all we need for a basic template. And some of these things are going to start to, oh no, I'm sorry, one last thing. After the while loop, we need to do our cleanup. So fgcugl cleanup. All right, this is our basic template. Let's check and make sure everything's working first. So I'm going to do a build. Doesn't matter if you do build, solution, or project. I just typically do the project out of habit. These warnings are normal. They come out of the fgcugl code, and it's because I'm wrapping some libraries and I'm keeping us from having to use names like gl, float, and all that as variable types. We'll be using things like double and float and things like that. And then this warning is normal when you first compile a project, and it usually will go away. And even if it doesn't, it's okay. It's just a warning. But our build succeeded, and we should actually be able to run this. Right now, we're just going to get a window. So there's our console window. And here's our breakout window, our OpenGL window. And notice it's not resizable. I don't get the little arrows that let me resize it. All right, so I'm going to close that. And once again, Windows isn't catching or letting OpenGL capture the window closed event. I'll look into that later. It is working in the Linux version fine. But I'm going to hit stop debugging up here with this red square. All right, now this is a good template that we can use anytime we want to start the next lab and we want to start from a clean file, which you're usually going to want to do. All right, it's very, very difficult to pull all the stuff out of one lab to start the next lab. Later on, we may have labs where we're just adding to an existing, but especially once we get the game going. But for right now, almost every lab, you're pretty much going to want to start from a new file. So here's what we can do is we can come over here to the project menu and we can say export template. So I'm going to click on that, and we want a project template. An item template would mean just that, like this file, but we want to actually store this whole project with all the settings we did. All right, we're doing it from this project, Breakout 2. I'm going to say next. All right, and here, let's name the template Breakout. And we could even do OpenGL, Breakout OpenGL. Well, actually, we don't need that there because in the template description, we can put something like C++ OpenGL Breakout game. Okay. And then we don't need to worry about any of these other things. This is nice. It's going to open up Windows Explorer to show us where it saved the template file. So I'm just going to hit finish. This is because I've been doing this before. So you should not get this error. But even if you do, just say yes. All right, and here it's opened it, and let's see where it's at. I'm going to try to expand this, and it's not really going to show it. You can see it's in Documents, Visual Studio 2019, My Exported Templates, and it's saved it as a zip file. I can go in and go back here to Documents, Visual Studio 2019, my exported templates, and there it is. And I can even open this zip file and I can see what's in here, right? So I've got this template icon, my C++ file, the project file, project filters, and a Visual Studio template file, right? So nothing real big. Notice the fgcugl, cpp, and h file are not included because we're linking to them in their own directory, that repos, documents, repos, fgcugl. So they're being linked from here. All right, so, but let's watch this. I'm gonna hit close on this, and I'm gonna close this project. I'm gonna do close. Well, actually, I'm just gonna close Visual Studio. Well, no, I'm gonna do close the solution. Close solution, and that'll close this whole thing. All right. And now I'm back to, I've got a blank Visual Studio open behind me, and I've got the what would you like to do dialog again. And I could just click on here to start Breakout 2. But let's say I was going to start on Breakout 3. I was ready to start Breakout 3, and I've already done a bunch of stuff to Breakout 2. I want to start from a fresh project. So I'm going to click Create New Project. All right. And notice I have my empty project up here, but if I scroll down now, look, there's Breakout as a template, C++ OpenGL Breakout game. So I'm going to highlight that and do next. All right. Once again, I need to name it. So I'm going to call this Breakout. Let's say this is for Breakout Lab 3. I want it to be in my documents repos. I want the solution and the project to be in the same directory. I hit Create. And now I have Breakout 3. Now it looks like I don't have anything, but if I start to expand header files and source files, notice my files are here. If I click on this, look, I've got the full file. And if I right click and go to Properties, look, here in C++, I have my include directories are all set. Down here in the linker general, my additional libraries are all set. In input, my libraries are all set. So right now, this looks just like a fresh Breakout game, lab ready to go for me to start editing. And I'm not messing with Breakout 2. This is its own project. If we go out to our repos, documents, repos, notice I have a Breakout 2 with its own source file. And here, Breakout 3 now, I have its own source file. So when I'm ready to start Lab 3, I would already have a brand new, and likewise, if it was time to start Lab 4, I can start with that template, and I don't have to relink in all the libraries and all of that stuff. So, okay, so that handles the first part of saving off Breakout 2 as a template. Now, what I'm going to do is you can delete Breakout 3, or you can just leave it there and edit it when it's time to do the Lab 3. What I'm going to do is I'm going to close the solution, all right, and then I'm going to show you guys, I'm going to remove it from this recents list since I'm going to delete it. You don't have to do this, but I'm going to remove it. I'm working on Breakout 2, and here, and I'll go ahead and open Breakout 2 solution. So I'm in Breakout 2 with all my stuff set, and then I'm going to go out here, and this is just to show you if you want to do it. I'm going to, not downloads, documents, repos. I'm just going to delete Breakout 3. So I do like Shift Delete, and I say yes, and then since I'm on a virtual machine, I have to refresh the window. But you can see I still have my Breakout 2, and that's what I'm going to be working on right now for the rest of this lab. So, but if I start a new project, I've got the template that can populate it for me. Okay, so that gets us through doing the template. Now let's get into Lab 2. In Lab 2, we want to we want to draw some circles on the screen, and so we are going to start with the fgcugl draw circle function. But let's make our window bigger because this window is really small. So let's say it's going to be 800 pixels wide and 600 pixels high. And that'll give us a nice good sized window. And then now down here in our main game loop, because we gotta keep redrawing it to keep the screen fresh, is we want to draw a circle. So we can do fgcugl, draw a circle, right? And then here we can see what our options are. We need an X and Y position, a radius for the circle. We can specify a color. It's defaulted to a value that's hard for us to determine what that is, but that's actually the integer for the color white. And then how many sides, and we'll get into what that means here in a minute, but let's just do the first three parameters, X, Y, and radius. And we can just kind of in our head calculate circles. The X and Y are to the very center of the circle, which makes it kind of nice to do. So we can just go right for the center. So half of 800 is 400 for our X, and half of 600 for our Y would be 300. So that'll put it in the center. And then let's just do like a radius of 10 pixels. All right. And then I'm going to build. I'll just build solution, that's fine. All right, and now I can run. And there we go. Here's our 800 pixel wide by 600 pixels high, and our we have a diameter of 20 pixels because we did a radius of 10 circle. All right, so let's do another circle here. Let's do another circle. I'm just going to copy this line. And let's say that we want this one to be at, what if it was at 100 pixels in the X and 100 pixels in the Y? Where would that put it? And let's do a 50 pixel radius, right? And then let's do something, let's change the color. Let's do fgcugl, and then let's do blue. All right, and then save. And then let's, oh, the debugger was still running. I noticed this red block, because remember I said closing the OpenGL window doesn't terminate this loop right now in Windows. So I'm gonna hit stop. And then I'm going to run, let me do a build. And then I'll run the debugger. All right, so we have our circle here in the middle, and then we now have our new circle. So notice we said 100 in the X, so it came over 100, and then we said 100 in the Y, and so positive Y's go upwards. And so we're in the top right quadrant of a number graph. If you had the vertical line and the horizontal line, the positive x's are to the right of the vertical line and the positive y's are above the horizontal line. So we're in that top right quadrant. So that our 0, 0 is this bottom left corner, and our y's go up, positive go up, and then our x's positives go to the right from 0 to whatever, however many pixels we set. All right. Okay, so let's just play around just a little bit more, and then you'll have a couple of things to do on your own. So I can close this, or I can just end. Either way. All right, so we want to, let's create some variables here to represent these position and radius. So we're going to create some integer variables for now, and we'll just say integer, let's do circle x, and we'll set that equal to, let's do window width divided by 2, and then int circle y, and we'll do window height divided by 2, and then we can do the int circle radius, and we'll set that equal to, for right now we'll keep it to get the same intent, or let's make it 20. That way we'll see a difference. And then we can just replace now. We can do circle X here and circle Y here, and then circle radius here. All right, and then I'm going to build. All right, and it's telling us that we're converting from int to float because I define these as ints, but these functions take float parameters, and that's fine. That means it's going to do some kind of an automatic conversion for us. Okay, so I'm going to run this. And the only difference is our center ball is a little bit larger this time. All right, I'm going to stop the debugger. Okay, so now let's come down here and let's do something to adjust those variables. So let's do something like for our circle X, let's minus from it the circle X times 2.5. Let's try 0.75. We'll see what this comes out to be. And then for our circle Y, we're going to do a plus equals. And actually, we can do, I think, a multiply equal. We could do a multiply equal here. And we can do our circle Y. Actually, we don't even need, I'm sorry, we don't need to do that. We just need to do 1.75. So we're actually, in a way, we're doing circle Y plus 0.75 times circle Y. So we'll see how that works out. And then for our, once again, we've got the semicolon. And then for our circle radius, let's increase it by 1.25. So let's do circle radius. And let's do times equals 1.25. And then what we want to do is now I'm going to copy these three here, and I'm going to override these three here, because what we're doing is we're declaring and initializing these variables here and using them to draw the first circle. Then we're adjusting the value of those variables using their current values. We're making mathematical adjustments, and now we're going to draw a second circle using the new values within the same variables. All right. So let's build this. All right, we're just getting some conversion warnings, no errors. And then let's run. All right, and now we've moved that circle up to the top left. All right, and how did that happen? Let me click on this window and then pull the OpenGL window, which looks like this document icon, whereas the black window here is the console terminal window. Okay, so how is that happening? Okay, well, we said the first circle coordinates were at the center of the screen. Then we said take the center, which would have been 400, and multiply it by 0.75, right? So we would have gotten a much smaller number. If we bring up the calculator, we can check these things. So we would have had 800 divided by 2 would be where the current circle X is. Then we multiplied it by 0.75. So times 0.75 is 300. And then we subtracted that from circle X, which we know was 400. So we subtracted that from the 400. And that left us with 100, and so our X was 100. And then for the circle Y would have been at 600 divided by 2, or obviously 300. And then we multiplied that by 1.75 times 1.75 gives us 525 as our new y coordinate. So we came up from the bottom 525, or just below the full 600. And then for the radius, we did the 20 times 1.25. So 20 times 1.25 would have just increased it by a quarter. So we went from 20 to 25 in radius. All right, and that gave us another circle. All right, so now what are you going to do for the rest of the lab? So after this code here, after this comment, or in the location of this comment, you are going to modify these variables again using some other arithmetic that you make up. So you're going to make up some new expression to modify these variables, and then you are going to draw a third circle. So this is circle 1, circle 2, you're going to draw circle 3. So don't declare new variables, just modify these again right in here, and then draw a third circle here. Then you're going to, so this is lab 1, lab 2A, lab 2B. All right, so for part C, you're going to need to initialize a random number generator. And so I'm going to take us out to our C++ reference site. And if we go to references, in here, I'm pointing you to where to start in the standard lib, stdlib, standard lib. We're going to find pseudo-random sequence generation. Now there are fancier random generators for C++ in other, but they are much more complicated. We don't want that. We want very, very simple. So you need to use these two commands to set up random numbers. And if I click on rand, which generates a random number, we can see it goes through how to come up with a range. And it shows in its example that it does srand first, and then it uses random. Okay, so in doing srand, you're initializing your random number generation so that you get a different set of random numbers every time you run your program. And you just have to provide it with a seed value. And here they show that they're using time with null in it, being current time, as the random number. Now you don't have to use time. You can just use a number that you make up as the seed value. But if the seed is the same every time you run the program, then you'll always get the exact same random numbers. So by using time, current time, it's time down to the milliseconds. So you're going to get a different number every time you execute your program. But notice you have to include standard lib for srand and rand. You also need to include time to get the time function. But so just kind of coming back though, you would use srand. So I'm going to click on that. And this shows you how to set up srand. And you would only do it once. You don't need to do it again. This is just showing what you would get for random numbers if you reinitialized it. But you only need to do it once. And then you would use rand to generate any random numbers. And then you can call this as many times as you need with different ranges to get the random numbers that you want. Okay, so let me talk about this and where you're going to do it so it all makes sense. So you don't want to do it inside the while loop, because the while loop is going to be going around hundreds of thousands of times a second, redrawing a circle, and we don't want the circle bouncing all over the screen faster than we can see. So we want to just generate a one-time random set of values for this for the fourth circle. The third circle we used arithmetic to come up with. So for a fourth circle, you're going to see we're going to want random numbers. So we want to generate our random numbers before we get into this loop for this run of the program. So somewhere in this area, we want for, oops, I have no idea what that just did. We want for lab 2C initialize sorry, random number generator. So that's the srand. And then here for lab 2.d, declare and initialize random circle, or we'll just call it random location and size values, size variable. And when we say size, what we really mean is radius. Okay? And then you will use those variables down here. So down here for lab 2E, assign random variables to circle variables. So you'd have a location, a random x, a random y, and a random radius that you declared and initialized up here using rand. And so down here, you'll just assign those values to your circle x, circle y, and circle radius variable. And then for lab 2.f, draw fourth circle. All right, and so what'll end up happening is you'll have this first circle drawn at the center based off whatever radius you had here. Then this will adjust where the second circle shows up, and you can pick different colors. You can also use different colors for all of them. And then you'll come up with your own arithmetic expressions to draw the third circle in a different location and size. And then you'll use the random values to draw the fourth circle. Now, in identifying the ranges to use, you need to think about what's the min and max. Obviously, min being 0, what's your max window width and window height. You can use these variables in your range. In other words, you can say from, you can say to random, you can say rand mod window height to get a y, and rand mod window width to get an x. And then obviously for your radius needs to be less than the needs to be some smaller value. Don't let a random circle end up taking up the whole screen. So use some smaller value so that you don't end up, it's okay if it overlaps a circle somewhere randomly, but it shouldn't be so large that you can't see anything else on the screen. So you'll need to declare and initialize those random variables there. Okay, and that will finish lab 2. And then you'll just need to upload this source, only the Breakout CPP file you'll need to upload to Canvas after you've updated it. Run it a couple of times so that you can see you get a different random circle each time. You know, in other words, the fourth circle ends up a different size and in a different random location. It'd be nice to do random color, and I can help with that in the future. but for right now that might be a little bit more difficult. So don't worry about random color, you can just pick a color. And this way, if you pick one color that's different than your others, you'll know that that's your random circle. Okay, that's it.